Welcome to Sanjaya Uvacha lecture series of the month. So, as many of you may already know, today is a special day in the history, especially the technological history of India. During the government of when Atal Bihari Vajpayee was the prime minister, the then government has conducted a nuclear test on May 11th, and from that time onwards, May 11th has been celebrated as the National Technology Day to acknowledge the development in the field of technology. And when it comes to technology, we know that one of the most fundamental thing needed is the methods. And we have a glorious, long history in metal manufacturing, metal refining, etc. If we look around even now, there are many Indian companies who leads the metallurgy related field around the globe, including Vedanta and the ArcelorMittal, etc. So today's lecture is from Professor Rishidas sir, who is an associate professor in Government Engineering College, Barton Hill, Thiruvananthapuram, who extensively writes about Indian technology traditions, Indian Sanatana Dharma related topics in social media. And we'll be listening to his lecture, his presentation on this particular topic. So over to you, sir. We can start. Last 10-15 minutes, we'll have question answer. So whoever has questions, they can either post here in the chat box or they can ask directly at the end of the session. Yes, sir, you can start.
A very warm namaste to the participants and to Amrita School of Spiritual and Cultural Studies. Today is the National Technology Day. Technology, history, tradition, etc. are intermingled in an inseparable way throughout human history. There may be different opinions, but human history is always was and is always driven by technology. And the technological advancements, when these technological advancements started, nobody knows. Probably when the first human beings started to make tools, these technological advancements may have started. Initially, there were stone tools. There is a big problem with these stone tools. Stone tools cannot be reused. Once a stone tool is deformed or it is somewhat blunted, it has to be thrown away. Then, during perhaps the 8th millennium BC or something, there are contentions regarding that. Someone extracted copper. It is relatively easy to extract copper from its ores. Simply by heating, copper is found as its sulfate ores in nature. If you heat copper sulfate ores at a high temperature, for a period of time, we will get copper. So, human culture or our civilization got its first metal which can be used for practical purposes. That was copper. Copper can be shaped, reshaped, it can be reused, and perhaps the first principles of reuse started with copper. Then someone found that if copper is alloyed with tin, we get bronze. Bronze is a superior material compared to copper in terms of strength, in terms of earth-keeping qualities, and perhaps in terms of its malleability. So a stronger material with better qualities. So from copper, we entered into bronze. And all the classical great civilizations were the Bronze Age civilizations, including our Indus-Saraswati civilization, the great civilization of Egypt, great civilization of Mesopotamia, the great civilization of China, all were Bronze Age civilizations. It's relatively easy to extract both copper and tin. And if you alloy copper, alloying means mixing copper and tin in particular proportions. Perhaps many types of bronzes exist. If you alloy, say, 90% copper with 10% tin, you will get some typical bronze. And this bronze was once the most valuable material known to humankind. Gold was precious, but bronze was more valuable because we cannot shape tools using gold. Gold can be used only as a measure of wealth and as a means of exchange of value. But bronze can be used as a practical material, which can be used to make tools, which can be used to make weapons, so and so. So, civilization, as we know, started with bronze. But iron was known to man. There are some iron meteorites which have existed in Earth in its pure form. And from the tomb of Pharaoh Tutankhamun, among the many artifacts and objects of gold, a very small iron knife was found. A very small iron knife. That iron was obtained from a meteorite which was obtained by ancient Egyptians from the Sahara Desert. Probably the Pharaoh Tutankhamun may have considered iron as a material of value hundreds or even thousands of times that of gold. That was the status of iron around, say, 1500 BC. Tutankhamun's time was around 1200 BC, but iron was known to man. There is something like iron was known to man around that time. And nowadays, a lot of explorations have taken place in Tamil Nadu, particularly near the place called Peru, a place near Coimbatore, where a large number of iron smelting mechanisms were found. And they were dated to be around 2200 BC. That news appeared in media perhaps a year ago. So Egyptians knew about iron at around 1200 BC or 1500 BC, but there is a strong evidence that Indians knew and Indians were able to extract iron from their ores in a large scale much earlier than Egyptians, around 1000 years earlier than Egyptians. So, Iron Age, that is iron becoming the principal material of tool making, should have started from India. There is no doubt regarding that. And before the findings in Adichalu, that is near Karur, it was believed that some place near Varanasi, it was in some place near Varanasi, around 3,800 years ago, was the first place in India where iron was practically used. But nowadays, all those are being modified. All those timelines are being modified. It is being conclusively proven that iron was known to Indians, particularly South Indians, at least 4,200 years ago. Indians knew how to extract iron from iron ores. It is very, very difficult to extract iron from iron ores. It's not as easy as copper. The difficulties arises from the fact that iron is a much more reactive metal than copper. To extract iron from its ores, a furnace will have to be kept at a very high temperature, around 1,200 to 1,500 degrees centigrade, for a very long time, some 8 or 15 hours. Very high temperature will have to be maintained in the furnace. And during that time, a reducing agent, carbon without any impurities, will have to be charged to that furnace. So the technology is not that much simple. Extraction of copper is relatively simple. As I said earlier, if you heat copper ore, copper sulfide, at a high temperature for a particular period of time, a few hours, what will be left will be copper. But iron is not such an easy metal to extract. To extract iron from its ores, a very finely defined process is needed. What are the ingredients which are to be put into the furnace? How much time the furnace is to be kept alive at a high temperature? And to keep the furnace at a high temperature for a particularly long period of time, air has to be blown through the furnace at a relatively high rate and velocity during the entire process. So, in people of India, particularly people of South India, were the first group of people or the first civilization which was able to extract iron from its ore. As I said earlier, humankind knew about iron. There were some iron meteorites which have fallen to earth long ago. From that, we know that iron was present in earth. But that supply was very, very, very limited. But iron ores are abundant. Iron is one of the most abundant elements in earth and even in universe. So we cracked around 4,000 years ago the method to manufacture iron from its ore. But that is, the story doesn't end there. Iron which is obtained from furnaces are not of very high malleability or workability. Iron which is directly obtained from the furnaces contain a lot of impurities, and the impurities will have to be removed. A large percentage of impurities can be removed by repeated heating and hammering of iron. And after hundreds of cycles of repeated heating to around 700 degrees centigrade and hammering, we will get iron of some good quality. But that iron, which is directly obtained from furnaces, has some great demerits. The first demerit is that most of the time, that iron is not that much malleable. it cannot be worked to perfect shapes. It will not keep a good edge. And above all, it will easily corrode. Corrosion, as everyone knows, corrosion is the greatest enemy of iron. If we leave an iron object to the elements, it will corrode, it will start corrode within, say, hours or even days. And perhaps in a few years, every bit of iron in that artifact will be converted to rust. So rusting and workability were the primary demerits of the iron, which was manufactured during the second and first millennia before the Common Era. So who solved that those problems of iron? That too was solved by Indian technologists. I will use the term technologists because the solution methods used by those early metallurgists or artisans were so complicated that they must have analyzed the problem. Just like we analyze problems using algorithms and case studies now. And after a long period of studies, they may have found an optimum solution. And they found that too in South India. They found an optimum solution around 2,600 or 2,700 years ago. Those timelines are always shifting backwards. That is why I am somewhat pensive in declaring those timelines. But we can very confidently say that high quality steel was being manufactured from South India around 500 BC. And the artisans of South India devised a process called Crucible Process for the manufacturing of steel from iron. As you know, steel is a superior material compared to iron. Basically, steel is an alloy of carbon and iron. But we were able to manufacture special grade steels too, which had highly specific and highly superior qualities for certain applications. So what is this crucible process? In crucible process, what is being done is that the iron which is manufactured from the furnace process is taken. Then it is mixed with appropriate amounts of charcoal and sand, and it will be sealed in a clay crucible. And that clay crucible will be heated for hours. The exact duration of heating, the exact temperature at which it is to be heated was only known to the master craftsman and his assistants. And after that process, the crucible is taken out and it is allowed to cool down naturally. And the resultant object was very high quality steel. And that steel was known as urukku in southern India. Urukku or urukku in Malayalam. But it was known as wootz in the Western world and Middle East. And there was a trade mechanism which extended from the western coast of India to the Mediterranean coast, which brought the urukku from Kerala or the southern India, then transported it to Damascus in present-day Syria and rebranded it as Damascene and sold for prices equivalent to that of gold. And this trade may have started around 500 BC. So basically, the Damascene is not manufactured in Damascus in Syria. It is basically a rebranded steel. It is brought from India, southern India. Then it is taken to Damascus in Syria. Damascus was a trading junction, and from Damascus it was exported to the Western world and the current Western world and Egypt. And everyone knew that this Damascene is not coming from Damascus. The early empires, early kings and emperors of Europe knew that it came from its precise location. Romans called Damascene as Syric steel. Syric steel means steel coming from the Chera country. Chera country means the western coast of India, or we can say Kerala. Syric steel. But for Greeks, it was Damascus. For Romans, it was Syric steel. And perhaps the Macedonian king, Alexander, came to India with an intention of getting hold of the technologies related to steel manufacture. It is widely believed that the only object which Alexander took from India was around 100 talents of high quality steel. 100 talents means around 3,500. I am not sure about that. Around 3,500 kilograms of steel. Alexander did not take away gold from India. He was unable to capture any slaves from India. Basically, he was frightened by the armed might of the Nanda Empire, and he retreated. But before retreating, it is widely guessed that he took some 100 talents, around 3,500 kilograms of high quality steel from India. The only objects Alexander took with him from India are, one thing is this high quality steel, and the second thing is a set of a kind of parrots known today as Alexandrine parrots. He was very fond of parrots found in India. In North India, relatively large parrots are found, and for North Indians it is tota, but for the Western world it is now known as the Alexandrine parrots. So we, from iron, we graduated to steel, and for around 2,000 years, India was the only place from where good quality steel was obtained. Two more sources were there. One place is Eastern Europe. They manufactured, but it was far later. They manufactured what is known as bullet steel. It too has superior qualities, but its qualities were much inferior to our urukku, that is the wood steel. Then, after the South Indians manufactured high quality steel, after that, around 1,700 years later, the Japanese manufactured steel of similar quality. They called it tamahagane. And it is, in Japanese, it has got some flowery meaning. So even then, the large-scale manufacturing of steel was limited to India till around 1700 CE. That is, till the British established their colonial rule in India. From 500 BCE to around 1750 or 1800, India was the only source from which high quality steel was manufactured and exported. And we manufactured not only, we manufactured different qualities, different levels of steel. Wootz was not the only material, only strong steel which we have manufactured. Different artisans, different blacksmith communities all around India manufactured steels of very high quality. Everyone knows about the iron pillar in Delhi. The iron pillar in Delhi stands resisting the elements for around 1,600 years. It was manufactured by King Vikramaditya II of the Gupta dynasty. It's a massive piece of steel. It is basically, it's a special grade steel. It hasn't rusted for 1,600, around 1,600 years. If we leave an iron object to the elements, we can easily observe how it rusts in front of our eyes. And if we leave a knife made of iron outside our home, exposed to the elements, we can surely see that within 3 or 4 years, it would have completely rusted. But here we have an iron artifact. It is not iron. I do have used the term iron pillar, but it is not true. It is steel. It is, we have an iron, a special grade steel pillar, which resists elements for 1,600 years. Now, how may have this huge iron pillar of around 7 meter height and 600 kilogram weight may have manufactured? It is a question which needs a thorough analysis and a thorough thought process. Even today, it is very difficult to manufacture a non-rust-resistant iron pillar of this size and magnitude in a perfect manner. If you look at the crown of the pillar in Delhi, you can see that the artifact installed on top of the pillar still retains its original glory. Still retains its original glory after 1,600 years. Now, how may have this steel pillar may have been manufactured? It is a masterpiece of technology of that time. I have no other word. It's a masterpiece of the prevailing technology during, say, during the period 4000 CE. Now, I have mentioned earlier that by rudimentary furnaces, from rudimentary furnaces, we can manufacture iron. And through the crucible process, we can manufacture steel of very high quality. But The steel that is manufactured through the classical crucible furnace is not 100% rust resistant. Firstly, our artisans or our early technologists may have tweaked or may have modified the crucible. It was now established with almost certainty that 100% certainty that the secret behind the rust resistant property of the iron pillar of Delhi is its unique combination. It is a combination, that particular steel is a combination of iron, carbon, and phosphorus with very, very, very small quantities of sulfur. It's very difficult to eliminate sulfur from iron because almost all iron ores contain trace elements of sulfur too. So some negligible percentage of sulfur will get into the iron and steel. But our ancestors devised means to introduce introduce phosphorus into steel in highly controlled quantities. And they were able to eliminate sulfur from steel through some process. Introduction of phosphorus and elimination of sulfur, and introduction of limited quantities of copper. The combination of the chemical combination of the iron pillar of Delhi is estimated to be around 0.2% of carbon, some 0.7% to 9.9% of phosphorus, and about 99% of iron itself. The percentage of sulfur which was found in that iron pillar was negligible. It was found only in parts per million quantities. So that unique combination of elements gave that artifact its rust resistant properties. That is why it survives even now. And during its survival, some invaders tried to destroy it by cannonball strikes. Using cannons, they tried to destroy it. Nobody succeeded in that. But some small dents which point to that cannonball strikes are present in that iron pillar. Now, some guess about how our technologist ancestors have manufactured. They modified the crucible process. The modified crucible process introduced phosphorus. How can phosphorus be introduced into steel? There may have been different ways in doing that. One possible approach is to use charcoal derived from trees like tamarind, which contains relatively higher quantities of phosphorus in their wood. It is only a possibility. And another possibility is that they may have introduced small quantities of rocks bearing phosphorus. Phosphorus too is found in nature. Phosphorus ores are there. In controlled quantities, they may have introduced phosphorus bearing minerals into the crucible. And that modified crucible process might have produced the special grade steel needed for the construction of the iron pillar. So the special grade steel was obtained. But the crucible process, which was traditionally employed in India, was able to produce only a half kilogram or at most 1 kilogram of steel per crucible. That too is a guess because the technologies are irrecoverably lost. What we can guess is from the obtained artifacts. The weight of that pillar is around 6,000 kilograms. Its height is around 7 meters. Through one crucible, what we can produce is at most 1 kilogram of special grade steel, which is needed for the manufacture of the iron pillar, rust resistant iron pillar. How all these iron, special grade iron, special grade steel boards, which are obtained from the crucible process, can be joined together to form that massive pillar. For that, they used a technology called forge welding. Forge welding is known to man for around 3,000 years. But here, forge welding at its technological limits were used. To manufacture steel, special grade steel required for the construction of the full iron pillar, the artisans need at least 10,000 crucible steel obtained from 10,000 crucibles. Then they should forge weld the steel together, steel bolts together. Forge welding is done by hammering together steel artifacts heated to red hot temperature. Red hot temperature means temperature greater than some 800 degrees centigrade. Heated, the objects which are to be forge welded should be heated together. Then they have to be hammered together, not one or two times. They have to be hammered together hundreds of times. Then only a perfect forge weld will be obtained. What we need is thousands of forge welds, which will stand the test of time for millennia. So this forge welding must have been done by our ancient technologies with very strict levels of quality control. Otherwise, at least some forge welds of the iron pillar may have split open by now, but not one weld has been split open even after 1,600 years ago. So the iron pillar of Delhi is an example of quality control at its highest level. It is an example of ferrous metallurgy at its highest level. It is also an example of quality control at its highest level. Now, this iron pillar in Delhi is not a standalone artifact. Similar structures even now can be found all around India. It can be found in Thar in Madhya Pradesh. The iron beams of Thar of Madhya Pradesh are even larger than the iron pillar of Delhi. But it's broken down. Iron is a very important strategic material. Some king or some emperor may have broken down a rust-resistant pillar and may have used it for some other purpose. But in Thar, these iron pillars can be seen even now. Then in Sun Temple Konark, we can find, even now we can find iron beams of massive size, massive size, weighing tens of kilograms. But the iron pillar in the Konark temple doesn't appear to be the rust resistant variety of iron. It is some form of high strength steel. Then again, in Kotajadri in Karnataka, we have an iron pillar, which is said to be even older than the iron pillar of Delhi, Kotajadri. It is still standing. It has rusted partially, but it is also a very much narrower steel pillar than that of the Delhi pillar. The rust has had some effect on the iron pillar of Kotajadri, but a 2,000-year-old iron pillar still standing is a wonder itself. So, ferrous metallurgy reached its pinnacle of glory in India. Basically, the rest of the world was able to manufacture the same quality steel only after around 2000, only around 2000 years after we have manufactured. But we have give credit to the Western world. They have scaled it up. They modified our crucible process. But our crucibles were able only to produce 1 kilogram of steel at a time. But they have modified the crucible process in such a way that their crucibles during the 19th century were able to manufacture steel at a much larger scale. Western modified crucible process is capable of producing tons of steel in one batch. Crucible process, even now, even in 21st century, crucible process is widely used for the manufacture of steel. But somehow, in the region or in the civilization where all these have started, flourished, and matured, the history of the glorious tradition is forgotten or almost completely forgotten. Nobody knows that we were the number one in metallurgy for around 2000 years. Even now, the Western world sees India as a land of snake charmers, a land of bullock carts, and a land of, say, half-clad farmers. And now and here and there, they produce some cartoons. They write some articles lampooning our achievements in the field of science and technology. But I have presented this just to remember the audience that we were not a backward civilization in the field of technology. We had the most advanced technologies for a very long period of time. But unfortunately, we were unable to sustain the technological growth. We were able to sustain that technological growth during a particular period. That period was from around 300 BCE to, say, around 600 CE. During that time, in a particular period of time, during that period, that is during the Maurya Empire, India was the foremost superpower of superpower nation of the world. It is attested by Western historians. We accounted for at least 40% of world production. We accounted for around 40 to 50% of world population. All that was achieved only due to our advancement in the field of metallurgy and associated technologies. So we have nothing to be ashamed of, or nothing to be, we have nothing to worry about our civilization. Our civilization had made massive, massive technological advancements. And a few days ago, I think the previous Wednesday, CNN published an article. And if you go to the CNN website, I think it's still, it can be found still in their front page. And that article is around about the iron pillar of Delhi. And they wondered how it was manufactured, how they were able to manufacture such a wonder 1,600 years ago, and how it remains untrusted even now. But sadly, we ourselves doesn't consider the iron pillar as a wonder. We consider some other structures as wonders of the world. That is the downslide of our civilization. We never value what is ours, and we give a more value and more importance to what is found outside. Only when we are able to correct that, we will be able to appreciate our achievements in the past, in the present, and our achievements, which will be, without any doubts, will be made in future. With these words, I conclude my presentation. The audience can ask questions if they have, and I will try to answer those questions with the best of my ability. Thank you.
Thank you, sir. So, sir has given an overview of our metallurgy heritage, especially with a focus on iron. And now we know that it's a steel also. It's not just iron pillar, but there was some.
It's a special grade steel pillar. We have to correct it. It's a special. There are steels like this, maraging steel. It is a special grade. It is classified as a special grade steel. So we should first stop classifying it as an iron pillar. It is a special grade steel pillar.
Okay. So now we'll have around 10 minutes. So open for questions. So request all of you to actively participate. Either you can post in our chat box or ask directly by raising your hand.
I will also answer questions if they are posted in my email ID. You can give my email ID to the audience.
Okay.
If questions are asked, I will try to answer with the best of my ability.
Yeah, if somebody needs, I will share his email ID so that you can continue to be in touch with sir to get more clarity, more detailed.
There's one question: is this art still alive in the South? My answer is yes, because I have seen with my eyes around 30 years ago the process, the iron manufacturing process, the iron steel manufacturing process, the conventional steel manufacturing process in a place near Vizhinjam. Vizhinjam is now famous for its upcoming port. And even now, there are local blacksmiths in Kerala who know how to manufacture steel from iron ore by the conventional steel manufacturing process. We have different names. Names are not that much present here. Purana Kidam, Purana Kittam. These are the names given to slag, the unrefined iron, etc. And one of my friends said that, told me that in the Kottayam region, those furnaces can still be found when during excavations for the structural activities of building construction.
Okay, so there is another question. Do the same steel has been found in other parts of the world for the same period? So maybe from
not for the same period. We found the secrets of steel around 700, 500 BC. Wootz. It is known as Uruku or Uku locally. It was known as Damascene and wootz in the Western world, and particularly in Rome and Italy, it was known as Ceric steel. There lies the clue. And some persons say that it denotes to Sri Lanka. Some persons conclude that it refers to Chera country, Cherobrata. But whatever it may be, Sri Lanka, whether it is Sri Lanka or Kerala, it belongs to the same geographical region. There is not much technological or cultural differences between southern India or Sri Lanka. And the Eastern Europeans found, perhaps they reverse engineered. It is assumed that they reverse engineered this Damascene, and they found a way to manufacture a type of steel called bullet steel. In the Slavic group of languages, bullet means steel itself. For us, Uruku is steel. Similarly, for Slavonic languages, bulat is a synonym for steel. It is assumed that they found the way to manufacture the bullet steel sometime during around 300, 400 C. Then Japanese found, but the bullet steel was technologically inferior to our steel, wood steel. But the steel which was manufactured, found in Japan during around 1200 C. I just forgot its name. It was of level similar to our wood steel. It was from that steel the famous samurai swords were manufactured. Samurai swords are still very famous. These two, the bullet and the tamahagane, that is the name for the Japanese steel. Tamahagane were the only comparable steels which can be in some way compared to the steel manufactured in India. That is Uruku or wootz.
Thank you, sir. Thank you. I think now we have a technical question. Is there any degradation in the property of the mentioned steel structures? Maybe the pillar, which you have mentioned, with the progressive exposure to magnetic and electromagnetic radiations, not just oxygen and other things.
As far as I know, there is no degradation with the due to the exposure of electromagnetic radiation. As far as in my knowledge, my knowledge is limited. In my knowledge, there is no degradation.
Hi, sir. It's Dhurandhar here. So basically, in the initial crucible process, there was an actual rust film created deliberately, which actually protects the steel. It's actually that there is actually a layer of rust using phosphorus, which basically protects the whole iron pillar, the steel pillar structure itself. And as the question was, there is a small degradation, because you see there's an inscription carved there, including a name, Pramshu. It used to be pronounced Pramshu in the earlier Sanskrit works, but now when it was on the pillar, there is obviously a little bit of change and flow. So now it's pronounced Pranshu in the later Puranic literature. So basically, you can say that before the iron, and that's how we date. One of the ways to date the iron pillar is that the text before that used to use this term as Pramshu is something who was there before the universe was created. हम क्या कहते the ऋग्वेद मंत्र, right? वो कौन था जो था धरती से पहले विद्यमान? That term is Pramshu. So Pramshu, so the word before in the older texts, very few of them survived before 400 AD anyway, has a different way to spell that the m sound, and it becomes a n sound, and it's basically, they say, because it was carved on the pillar and there was a flow, there is still some action going on. It is so minute, it is so minuscule over thousands of years, but there is some action. Yes, there is something happening. So maybe, maybe another 10,000 years, we may see a little bit of it. But that's something. There's always a little bit of degradation or something happening. Time is one of the most powerful objects. And that
time is will degrade everything.
Exactly.
For sure.
Yeah.
Okay. Now, one more question from Uday Banasingh. How we can know exactly that technology which is very valuable? So basically, do we have access to that technology?
Sir, as of now, we can only guess how it was manufactured. We can basically interact with the older generation blacksmiths. I have interacted with a lot of them. And from those interactions, we can do some reverse engineering in our mind, how it may have done. But the problem is that now iron is a very easily available material. Iron scrap, high quality iron scrap is available for rupees 20 per kilogram. So these type of ancient manufacturing techniques are not valuable in terms of money. Now, that is why these technologies have practically vanished from our cultural and technological scene.
Okay, so thank you. Any other questions?
So I'll give you an example parallel to the time when we were developing our steel and all these properties, and we don't know really how we developed it. Romans were developing a thing called the Roman concrete. Now, if you see a modern concrete,
that is
it lasts
another thing.
1,500 years. That's 2,000 years is still there, under the sea.
That is another mystery. They have superior quality concrete some 2,000 years ago.
And in their composition also phosphorus, like somewhere in this material metal, this element phosphorus has some sort of a property which we basically, some of them realized in ancient times, and then later on we didn't need it, so we forgot. That's
structures constructed using Roman concrete still stands.
Exactly.
We can see them.
The naval piers and everything, 2,000 years underwater, and they're still standing. And modern ones degrade immediately, right? They're rebuilding, they're doing the maintenance on that Bandra sea link and everything already. But the Romans,
the collapse of the Roman civilization, we lost that concrete technology for around 1,000 or 1,500 years. Then it was reinvented around 200 years ago.
Yeah, 1860s. Yeah.
Thank you for the comments. Any other questions?
No, sir. Excellent. Yes. We can understand each and everything.
So I think no further questions. I will share sir's email ID with. Okay, I think there is one question from Tanmay. Okay, where did Alexander saw the manufacturing in South India? No, actually, yes, sir, you can answer.
Alexander, it is a guess. During Alexander's time, steel was being exported from South India. It is there is no doubt regarding that. During that time, Romans knew Indian steel as Xeric steel. The Greeks knew Indian steel as the Damascene. But everyone knew that steel, the source of that steel was not Damascus. Even the traders of Damascus were frank in admitting that that steel came from India. But the exact source, they kept a secret. Alexander's guru, Aristotle, was a very widely traveled man. Perhaps Alexander got the information regarding the source of the high quality steel from his guru Aristotle. And we have to accept the fact that Greeks at that time were a highly inquisitive civilization. They have traveled to many parts of the known world, and they kept records. Many Greek travelers must have traveled to South India. They may have traveled back. They may have traveled back and given notes to the philosophers, the learned men of Greece. And in that way, Alexander got knowledge about the Indian steel, its source, and perhaps the rudimentary manufacturing process. And again, I will state one more thing I just forgot to mention. In Mahabharata, there is a parva called Musala Parva. It tells the story of an Ayasa Musala. Ayasa means iron. And the story takes place during the transition from the previous Yuga to the next Yuga, Kali Yuga. It is during that transition period an Ayasa Musala was found. That story is a poetic story, and I'm not going into that. An Ayasa Musala was found. An Ayasa Musala must have been a steel rod shaped like a musala. And from that Ayasa Musala, the Yadava may have manufactured very sharp iron blades, iron swords. And in their final battle, it is in Mahabharata, it is mentioned that they battled using Iraka weeds. But the actual meaning may have been to the swords using very sharp steel blades.
Thank you. Yeah, who is that?
Myself, Dr. Uday Bhansingh. Sir, I want to ask that is any book available in market for that information?
There are a lot of studies, scientific papers available.
Yeah.
And some of them can be found for free in internet. But as far as I know, there are no authentic textbooks available in this matter. And again, the export of wood steel from South India took place till around 1750 CE. There are verifiable records for that. But after British took over the administration, colonial administration, all the traditional iron smelters were closed down. The iron smelting communities were declared criminal communities. And British, after extracting the knowledge about the crucible process, forcibly shut down the entire iron industry of India.
Yeah. Sir, if you have material in this regard, can you place in WhatsApp group?
Yeah, I will collect and share. I will collect and post.
Okay, I will try to share the materials. There is one particular study by IIT Kanpur, and it is regarding the iron pillar of Delhi, but it also mentions various other aspects of the iron technologies of ancient India. I haven't included any references in this presentation because the subject is a very vast subject.
Yeah.
We should not limit its scope. If any presentation regarding any narrow subject is needed, I will try to present those subjects with relevant references.
Thank you, sir. You have given very valuable information. Myself, Dr. Uvacha Singh, Associate Professor, Central University, Himachal Pradesh, Dharamsala.
Thank you, sir.
Thank you all.
Namaskar.
Thank you. So we will close now. Namaste. Thank you all. Thank you, sir.
Thank you.